Welcome to our first ever episode of Fun with Felsic with our TV star, Emily Palmer Pocus.
Thank you, Chris. I'd really like to learn about the Challis volcanoes today. What can you tell me about them?
Well, the Challis volcanoes started in about 52 to 39 million years ago, and they formed in the heart of Idaho. Now, the reason that they formed in the heart of Idaho is kind of complicated. Are you sure you want to hear about it?
I really do.
Okay.
I think my first question is going to be, what are the primary rock types in this geological province, and how did they form?
Well, the primary rock types are basalt, tuff, and rhyolite. Our rhyolite here, our tuft here, our rhyolite here formed as part of one of our felsic rocks that are sticky, light-colored, and more floatable than our other types of rocks. Our other rock is our rhyolite. Oh, wait. Can we start over?
Just cut right there. Can you explain the different types of, try the basalt first.
So basalt are actually flows from the volcanoes, and then we have our rhyolite, our tuff, which comes from volcanic ash and debris thrown about by the volcano.
And then rhyolite?
And then rhyolite is the felsic rock that creates plugs and stops in our volcanoes, causing them to be super explosive.
So each of these rocks formed in a different way. This one, the rhyolite, formed as a plug of a volcano.
What?
Did that form as a plug of a volcano?
Not always. It forms a lot of different ways.
Okay, and how does this one form?
That one's from ash and pyroclastic flows.
And this one?
That one's from mafic rocks that are flowing out throughout the land.
Okay. Very cool. What are is the primary ages of the rocks in the geological province, and what are those ages based upon?
Well, most of the rocks are 51 to 45 million years old, and we know this from radiometric dating and also from superposition and cross-cutting of certain rock formations. Most of the volcanic flows and volcanic activity happened about 10 million years during 51 to 45 million years ago, but the bulk of the volcanic activity occurred only 6 million years. For 6 million years. Wasn't very long.
What are the major structural features of this geological province?
Well, currently most of the structures are extensional basins, rifts and gibbons, and calderas.
Great. What is the geological history of this province? How did it all come together?
The history is the stretching and the rifting and the volcanoes and the Challis fault. Most of this region formed long ago whenever the states of Washington, Oregon, and Idaho looked more like this gulf right here. Now, as this gulf had this plate right in the middle that was the Kula plate and the Farallon plate, and these two areas were fighting for dominance. And right here, right along this area, we have a diversion area where the seafloor was spreading and creating more mafic rocks. Now, as this plate subducted underneath our continental boundary right here, our margin, the subducting plate started melting way back underneath this crust right here and creating the Challis arc, which is formed by the subducting plate melting, creating a magma chamber, and then starting to expand upwards towards the surface. as it starts to reach this felsic, more sticky, heavier rock, it forms a plug and starts to back up pressure, and then as this pressure builds, it finally explodes and creates all kinds of ash flows, pyroclastic flows, ash layers that later on turn into your tuft and other rocks like that. And then later even form sedimentary rocks as the water and rivers start to erode, which actually created most of the sedimentary rocks that we now find in this Washington area up in here.
That's really interesting. How is the present topography of this province related to the geologic history?
Well, the present topography is mostly mountains, dips, cones, extinct volcanoes, basalt flows, and fault zones, mainly from the bending, uplifting, and ejection of magma from below.
From previous times.
Yeah, there's many things to go into it, but
What did that topography look like back in the history?
that looked more rugged and less worn down than it does today.
So I really only have one final question for you. Out of all of this that happens with the geology, what natural resources come from this type of environment?
Well, when you have this type of environment, you have lots of pressures, different types of rocks forming, grinding, which creates metals such as areas for copper, silver, lead, zinc, feldspar, uranium, building stones, gold. I mean, it creates a menagerie of different minerals and rocks that are available that we currently mine. The history of Idaho and the mining is created from these areas that were filled with minerals that created veins. We also have hydrothermal energy because of the current geology that's going on, heating the earth underneath. So this area is very hydrothermically active.
And are there any hazards related to this type of environment?
Well, currently this area is all inactive volcanoes, so we don't really have to worry about them exploding too often. There could be earthquakes, and mainly landslides are the main thing that you have to worry about currently. But luckily, we don't have to worry about these volcanoes coming off anytime soon. These don't have anything to do with the calderas and Yellowstone or anything, so we're pretty safe. These are old, extinct, not sure why they really happen type of volcanoes, but I want to thank you for coming and joining us today, Miss Palmer.
I really appreciate you informing me of all the no's and how's of the Challis volcanoes.
Absolutely, and next time, join us for more Fun with Felsic.
No, say, what do you say? What's the introduction? Welcome to Fun with Felsic. And then you jump out of the camera and I'm going to go, what are we talking about today on Fun with Felsic? Okay, should we start actually? Should we record some of this? Okay, should we start actually? Should we record some of this?
How much further on are you? Geological rocks were the tuft, the rhyolite, and the basalt flows that we just... Okay, give me some of that dirty rock action.
Dirty rock action? Dirty rock action.
That's all we get.